Okay, we're still eliminating the parameter, which again basically just means we're rewriting it in terms of x's and y's, and this time we've got a we got tangent and secant involved, which means we've got trig stuff going on, which means we're going to use one of our Pythagorean identities, and that's really all. Again, it's just those identities, those couple identities that we're using. Nothing else, nothing crazy. We're just trying to rewrite those. Just like yesterday when we graphed it, we are going to divide by 2 here. X over 2 equals tangent, right? Ugh. And then y divided by 5 equals the secant. And just like we used, it was secant squared minus tangent squared equals 1. Okay. Right, and you just plug it in. So we got a y over 5. I had to stop and think. Quantity squared minus an x over 2. Quantity squared equals a 1. Right? And so really it's a y squared over 25 minus an x squared over a 4 equals a 1. So that is it rewritten. Now, the problem of the parameters, right, and the restrictions on that. Here's the easiest thing to do. When we have those first 2 examples, we didn't have trig functions. It was just y equals and, just t's, x's, and y's. There was no trig involved. And so really, to find the new parameters, the new restrictions on x, it was very simple for us to just take our bookends of t and plug them into x equals whatever and get the new bookends. Again, of course, I'm air quoting bookends, but we'd get those numbers that way. The easiest way to get the restrictions here is actually to go graph it. That's why we graphed it first yesterday, so that you can have that. And so ultimately, if you go graph, I'm going to highlight different color. If you go graph these, right, and remember it's, zoom 6, then ultimately what ends up happening is you get a parabola and you see that it's, this way and this way, it opens up and down. And so really, there's no restrictions on x at all. You can plug in any x for that, and ultimately your interval over x, which I'm going to highlight and put over here, is just going to be negative infinity to positive infinity. Okay? And that's, we're just pulling it off the graph, right? Remember, if a graph, we got hyperbola, it's going there. It's a full hyperbola. There's no little restrictions. It goes from 0 to 2 pi as far as t is concerned. So just graph it, and that'll help you. Okay? So let's take a look at number 4. Okay, so we got x equals t cubed plus 1, y equals t cubed minus 1, and we've got restrictions from -2 to +2 for t. And again, no trig on this one, so really the only thing that you're trying to do is solve your first one for t so that you can plug it in. So x minus 1 equals t cubed, right? Because you want a y equals x something or other. Take the cubed root of x minus 1 and the cubed root of t cubed, right? And then plug this in there. So y equals the cubed root of x minus 1 cubed minus 1. Okay. You thought it was going to be a lot harder, but nope, those just cancel. So basically you have a y equals an x minus 1 minus 1, so y equals x minus 2. That is your equation, right? And remember, to get our new parameters, you're just going to take the -2 and the +2, and you're going to plug them in. We'll put them in a different color. Oh, let's go with that green. So x equals -2 cubed plus 1. So -2 cubed is a -8 plus a 1 is a -7. And x equals, you're going to do a +2 cubed plus a 1. You get a 9. So -7 less than or equal to x less than or equal to 9. Whoops, those are your parameters. All right, I will finish the last 2 in a different video.